Okay, everybody. So this is a quick video explaining where the absolute value comes from in the derivative of inverse secant. So if we look at the graph of inverse secant, it looks something like this. You can see if we look at the slopes, which is what the derivative represents, along this graph, they're positive all through here, and they're positive all through here. So the graph of the derivative should be positive everywhere, right? So if we actually look at Desmos's numerical derivative, so it calculates the derivative of individual points and then plots the graph, that looks like this. And you can see that the graph is positive both to the left of 0 and to the right of 0. Now, if we take the thing that we got in class and graph it, you'll see that it matches up with the derivative on the right-hand side over here, but it doesn't match up on the left-hand side. And the reason for that is we need this slope to always be positive. The 1's always positive, the square root's always positive, but the x isn't. So if I take this x and do something to it to make sure it's always positive, we'll be good to go. And the way to do that is put an absolute value around it. So now it matches up perfectly with that derivative, and we're good to go. Now, the reason that absolute value comes in has something to do with the way that the domain and ranges of secant and inverse secant interact, but for now, this explanation is good enough.